So you may have been tempted to say A because it certainly looked like the center of mass velocity was very special and is always constant in a collision. But this shows us why the center of mass velocity is constant and also shows us when. Because notice that it's directly related to the momentum of the system. And so we know if the system is isolated, then the system momentum is constant, and that's why the center of mass velocity is constant. But this system isn't isolated because the brakes are applied. And so there are external interactions which will change the momentum of the system. So the answer is B. Because the system is not isolated, the center of mass velocity will not be constant. Here is your strategy to solve this nasty problem. You take your original frame, you transform all the velocities into the Z frame. You have to calculate your initial energy in the Z frame. Careful, those are V in the Z frames. And then you just use this and you transform back to the original frame and you're done. But I want to clarify this problem-solving strategy. We just worked through and got this equation, but I don't want you to think that you can just magically use this equation all the time and find the answer. In fact, I'd like you to forget that you ever saw this equation. See, here's the thing. We had a case where this system started with some internal energy and ended up with none, and we wanted to know these two velocities. And we were able to work out this equation. But what if we gained internal energy instead of losing it? Or what if the unknowns were a different pair from what I just went through? That equation wouldn't have been useful at all. The point is that we have conservation of momentum and conservation of energy, so if we have two unknowns, we can solve the two equations for the two unknowns, but it's messy unless you transform into the center of mass frame. And then the fact that the total momentum is zero makes the solution easier. So this is the strategy. Transform to the zero momentum frame, write your conservation laws, and then solve the resulting system of equations, and then transform back to the original frame.